Here is a mixed review of composing functions. So first let's start with f of g of x. I want to pay attention because there's three functions listed at the top here. I have f of x, g of x, and h of x. So for this first one, I'm going to go into f and plug in g of x. G of x is 4x plus 3, and I'm plugging that into x squared minus x. So I'm going to replace x squared and a minus x with 4x plus 3. In order to do this, I might have to do some side work and figure out what is this squared term going to end up being. So if something's squared, it's multiplied with itself. So 5 squared is 5 times 5. 6 squared is 6 times 6. So 4x plus 3 squared is 4x plus 3 times 4x plus 3. Then I can also distribute this minus to both terms. So it's going to have a minus 4x on it and a minus 3. But I need to do some multiplying here. So 4x times 4x gives me 16x squared. The outer term, 4x times 3 is 12x. The inner term, 3 times 4x is 12x. And the last term, 3 times 3 is 9. And we still have that minus 4x minus 3 at the end. So lastly, I just need to combine any like terms. So for my x squared term, I have 16x squared. For my x term, I have 24x. When I do that, 12x plus 12x. But then I have the minus 4x from over here. So I have 24x minus 4x gives me a 20x. And then my constants are 9 minus 3, so I have a plus 6 at the end. So here's my f of g of x. Is 16x squared plus 20x plus 6. Okay. So let's see if we switch the order. So the next one says g of f of x. So I'm going to plug in f of x, which is x squared plus x, into g. So I'm going to look at that g of x, which is 4x plus 3, and replace that g of f of x. I'm replacing that 4 times x with what it was in terms of f of x. So instead of 4x plus 3, I'm replacing x with x squared plus x, since that's what f was. I just have to distribute here, which gives me 4x squared plus 4x plus 3. There's my g of f of x. We get two different functions. It was easier to find that second one. F of g of x was not the same thing as g of f of x. The next one down, I have f of h of 4. So I can write this as f of h of 4, which means I first need to figure out what h of 4 is. So I need to look at the h function for the first time. H of x is x minus 3 over 4. So I need to figure out what h of 4 is first. And it's going to be 4 minus 3 over 4, which gives me 1/4. So really I'm doing f of 1/4, which means I'm going to do 1/4 squared minus 1/4. When I plug into f of x, I'm going to replace both those x's. X squared is going to become 1/4 squared, minus x is going to be minus 1/4. And I get a decimal or a fraction, whichever is easier to write. We get negative 0.1875, or it might be faster to just write it as negative 3/16. Negative 0.1875. We're going to plug in another number again. We're going to do g of 8, which means I'm going to start with plugging in g of 8. So I'm going to do 4 times 8 plus 3. 4 times 8 is 32, plus 3 is 35. So I'm really doing g of 35. I'm going to go into g and replace that x with a 35, which will give me 4 times 35 plus 3. which is 143. Now I have a couple more functions to find. I'm plugging in x's, so I'm going to get out answers with x's in them, not numbers. I have h of g of x, which means I'm going to go into the function h and replace the x's with what g of x was. G of x is 4x plus 3. So I'm going to go into h, which was really x minus 3 over 4. And instead of writing x minus 3 over 4, I'm going to write 4x plus 3 minus 3 over 4. Replacing that 1x with what it is in terms of g. And I can simplify the top. I have 3 minus 3 is going to cancel. It's going to leave me with 4x over 4, which is really just x. So my h of g of x ends up just being x. If we work it the other way and do g of h of x, see what we get for that. That means I'm going to go into g and replace those x's with what h of x is. In other words, I'm going to have g of h of x is really x minus 3 over 4, which means I'm going to have 4. And instead of just an x, I'm going to replace it in terms of h. Instead of 4x plus 3, it's going to be 4 times x minus 3 over 4 plus 3, which I can cancel out 4 divided by 4. I'm going to get x minus 3 plus 3. And now I can cancel out those 3's, and g of h of x also ends up being x. So we're going to have this special kind of relationship where when we did h of g of x, we got x. And when we did g of h of x, we also got x. This is something specific that we're going to learn about, where when we plug in h of g of x or g of h of x, the order doesn't matter, we both get x. It is a special type of relationship that we're going to be discussing. So composing functions together, you may get the same answer out, you may not, depending upon your order, and there is a certain reason why.